Hey guys, okay, so this is the example for week 4. We just finished the notes in the previous video. There are the notes. We're going to look at them side by side. At the end, we'll look at them side by side. So this is similar to how you will do your practice problems in the Google form. So it says a sample survey interviews a simple random sample of 500 female college students and 550 male college students. Researchers want to determine whether there is a difference in the proportion of male and female college students who worked for pay last summer. In all, 410 of the females and 484 of the males say they worked for pay last summer. Construct and interpret a 99% confidence interval for the difference in the proportion of male and female college students who worked for pay last summer. So let's go ahead and start with state. So one thing that I like to do before I really get into my null and alternative hypothesis, I like to go ahead and do the parameter and context. So that way I know what I'm talking about. So let's say that P sub 1 is the true proportion of females, ladies first, of female college students. Who worked in the summer. And P2 is going to pretty much be the same thing. I'm just going to copy it and paste it. The only difference is that P sub 2 isn't going to be female, it's going to be male. So in the problem, they're saying that, that's weird. Don't know where I went. There we go. In the problem, they're saying that the null hypothesis is that there is no difference. That, remember, this is always going to be the same thing no matter what. The true proportion of women working minus the true proportion of men working is 0. That is always going to be your your null hypothesis. The alternative is where it's going to be different, because this is whenever you actually have to read the problem. So if you look up here, it says whether there is a difference. So that means this is going to be not equal to 0. We don't know if it's greater than, we don't know if it's less than, we just know that it's not 0. So then after this section, we get to go ahead and identify what we know. So the sample size for the first set of data. How many female students did they ask? They did a survey of 500. We can also go ahead and do N sub 2. The sample size for the male students was 550. The sample size. So out of those 500 women, how many were working for pay during the summer? So 410 out of those 500. The sample size for the second one, how many of those guys were working? And this is 484. Now, it is possible that these guys were like working at home, or they were working with their family and just not getting paid. If we were to convert this to a decimal, this is 0.82, and this is 0.88. We also know that our confidence level is 99%, based on the problem, because it wants us to construct a 99% confidence interval. Now, in order to find Z star, we're going to have to use the table. So if you look at the bottom of table B, where it says confidence level at the bottom, we have 99 right here, and then this says Z star. So a 99% confidence level has Z star of 2.576. Okay, and that's all for state. So we're going to go ahead and move on to the next step. We are going to plan. So in the plan, the first thing that we need to do is figure out, is it random? Did they randomly select these people? And if you look right here, it says SRS, which means random, simple random sample. The next thing, step 2, n sub 1 times p sub 1 has to be greater than or equal to 10. So n sub 1, the sample size of the first set of data is 500, times the first sample proportion, which is 0.82. We want to know, is that greater than or equal to 10? If you multiply it, you get 410. And 410 is indeed greater than or equal to 10. That's the first step. This is the second step. We also need to do n sub 1 times 1 minus p sub 1 greater than or equal to 10. So 500 times 1 minus 0.82. We want to know, is that greater than or equal to 10? And it is 90. 90 is indeed greater than or equal to 10. So that works. So the first set of data is good. The female set of data is approximately normal. Let's check the guys. So n sub 1, p sub 1 greater than or equal to 10. So they had 550 guys. Out of those, 484 out of 550 were working. Is that greater than or equal to 10? Oh, sorry, 0.88. Why didn't you do that? So 484 is greater than or equal to 10. So that's good. The second one, oh, sorry, that's not a 1, that's a 2. The next one is n sub 2 times 1 minus p hat. All of these are supposed to be p hats, sorry. P hat sub 2 greater than or equal to 10. So 550 times 1 minus 0.88 needs to be greater than or equal to 10, and that is 16. And 16 is greater than or equal to 10. So it is normal by large counts condition. Okay. So let's move on. Next we have the do section. So this is whenever we're going to plug everything into the formula. So that formula again is in parentheses, very important that you do the parentheses, p hat sub 1 minus p hat sub 2 plus minus z star. We're going to move it down just a little bit. There we go. That's good. Times the square root of p hat sub 1 times 1 minus p hat sub 1 over n sub 1 plus p hat sub 2 times 1 minus p hat sub 2 divided by n sub 2. Okay, so let's go ahead and plug everything into this formula that we know. So we have we'll do it down at the bottom. So 0.88 that's weird. 0.88 minus, no, p hat sub 1 is 0.82. Sorry. Yeah, p hat sub 1 is 0.82. So 0.82 minus 0.88 plus or minus z star, which we found in the first step, 2.576 times the square root of p hat sub 1 times 1 minus p hat sub 1 divided by that sample size, which was 500, plus the second sample proportion times 1 minus that proportion divided by that sample size. Okay, and then we're going to put this in our calculator. Remember to use Desmos. We're going to have low, high, and we're going to use Desmos. Okay, so let's go ahead and pull up Desmos. So, alright, so we're going to do parentheses. We're going to click in the place parentheses 0.82 minus 0.88. What was it? Yeah, minus our z star, which was 2.576, times the square root, and then we're going to have a fraction. 0.82 times 1 minus 0.82 divided by that first sample size minus. Now notice how I'm actually, I used to tell you guys all the time, I was like, make sure you're closing off your square root. In this case, we still want the square root. And so our low number is going to be 0.086. Oh, that's not right. I'm sorry. This is supposed to be a plus sign. There we go. That's correct. Okay, so our low number is negative 0.1168. So we're going to say 0.1167. And then we're just going to go back. I'm going to highlight this. And we're going to change this minus sign to a plus sign. So these are our two numbers. So we have, oh, that's weird. Okay. So our high number is, oh no, that makes sense. No, it doesn't. So we have negative 0.03 and negative 0.116. So our low number is negative 0.003. And our high number is negative 0.117. So now we need to go ahead and do our conclusion. So we're almost there, just need to conclude. Okay, so for our conclusion, we are going to say that we are not going to do that. Okay, so we are going to say we are 99% confident that the interval from negative 0.003 to negative 0.117 represents the true change in proportion of all male and female college students that work for pay during the summer. The interval suggests that there is a 0.3% to 11.7% difference between 0.3% and to 11.7% more males that work during the summer than females. And remember, this is college students, so if you want to put male college students that work more than female college students, you can. So here's what I want y'all to check out really quick before I run out of time. Here are the notes side by side. So we have our state, our plan, do, and conclude. And there you go. So we have our problem. It's completed. We're done. Awesome. The next video is going to contain one more example if you want just a little more notes.